What's up? Happy Monday, everybody. Let's see, let me see if I can get this sound right. How's everyone doing today? Let me know how the stream sounds. I didn't get to do a sound check like I wanted to. What's up, SVJR18? Good evening. What's up, 88 Opus? As usual, I got got the link for you already. I got the link for you already because I broke. I'm still trying to be too fancy. I keep breaking my automation for Google Classroom. Maybe one day you guys can like help me out on like a Friday or something, and I can figure out what I'm doing. Because I don't know. I think everything should be easier than it is. One day we'll make it all easy. But I hope everyone's doing good tonight. Tonight's fun because tonight is like the last big piece of the puzzle. Like you'll have all the information that you need now to go look at some of these other things. Like I think until we learn functions and scope, I think it would have been difficult to send people off to do their own thing. Until now, this is kind of the last topping, and I could have dropped it a little bit earlier. I definitely could have put it a little further in in front of the very first algorithm section, but I think it's a good idea again to kind of space things out this way to give your brain time to kind of pick up the other concepts, because this is kind of just wrapping those things up, to be 100% honest, and that's almost a pun a little bit, but yes. But thanks, 88 Opus. All right, I'm glad it sounds good. Let me just get all my windows and things set up. I have way too many tabs open. One day we need to do a poll to see, like, at the current time when we drop the poll, I want to know how many tabs people have open in their browser, because it gets pretty ridiculous. And I just cleaning up the desktop really quick. All right, let's pull up our curriculum. 34 across 3 browsers. That's not terrible. Across 3 browser windows. Is it 3 browser windows or is it 3 browsers completely? That's the question right there. But that's not bad. That seems about normal. 3 browser windows. What's your browser choice? I'm obviously a Chrome user, but they're all. I do like Firefox. Yeah, Chrome for the most part. It is a computer hog. It's a resource hog, but I like it. It does what I needed to do. I know when I tried to switch from that to Firefox, and it was fine for a little while. Some of the tools that I had gotten used to really was really weird. It really threw me off, really messed up my flow. So I switched back. I did use the Brave browser for a little while. I think I have it on here. I still have it on here. It's a Chromium based browser that kind of it really cares about your privacy. So you can see here, it looks just like Chrome for the most part, but it cares about privacy. But because of that privacy, I actually had a lot of trouble developing things. So I had it there were some times when I was developing stuff for this website, for some other applications that I was working on, and it would block certain things, and like I couldn't figure out why things weren't working. I think my Google Analytics and stuff wasn't working right when I was trying to test it. So it was it was really weird. So I stepped away from it just because of that. I didn't feel like messing with all the stuff. I could have used them both. I could have used it for personal browsing and used Chrome whenever I was doing development or checking on that, but it's all good. Firefox game present, all good. 27, Avro code 27 across 2 browsers. That's pretty good. I like the 34 across 3, 27 across 2. I think we're linearly scaling, and I like that. That seems about right. You get to around between 10 and 15 tabs, and you got to open up a new window for sure. I like that. Firefox really comes down hard on Firefox for security concerns. Yeah, I hear that a lot. I wonder what does anyone know what Downright uses? For people who are so security minded, I always wonder what browsers they use, because I think the conversation's always pretty interesting. He's probably using something like Opera or something random, not random, but different. Okay, uses Chrome. Dope. Okay, let's take a look at what we have tonight, and let's take a look at what we have for on Wednesday. We've done a lot. Like, look at, when I scroll down, look at how much we've already gone over. Like, think about where you started. Think about all that you picked up so far. And let's talk about what we're gonna learn tonight. You can see here, there's only 2 bullet points here. This is exciting. This is very exciting. This is why we're gonna take our time. Probably get started in the next couple of minutes, but we can take our time tonight. Tonight we're learning about functions. Functions are an integral part of programming. This will help you do a lot of different things. And I think it's a concept that now that we've learned so many other things, we can easily use this to make our lives easier and better. Lambdas, which are functions, they're anonymous functions, but we'll show you how to use those and see why you would want to use them. And scope. Scope is very, very important in programming, especially now that we've learned loops and everything, because we know how to do some logic. Scope is very important, so we need to know about that. So those are what we're going over tonight. And we will probably, I keep saying we're going to get to it, we'll probably have time to hop into exorcism, and we'll try to get it set up. I think we started to get it set up, but we'll try to start going through some of that stuff, because it's difficult to go through it when you don't know functions, because they kind of want everything done in a function because it's test-driven development, and maybe we can talk about some of that as well as go over some of them. But if not, we will definitely, that's all we'll do next time. We'll on Wednesday, we're going to talk about the different type of algorithms. We'll talk about how to do, like, bubble sorting and merge sorting and all that stuff. We'll go over those concepts. Not important that you at the end, I actually don't need you to know all that stuff by the end of next time, but I do want to get into some coding challenges so we can start figuring out, again, practicing what we learned in the first algorithm section, learn how to break down the problem. And these will be tougher problems. We'll break them down and we'll learn how to attack them. And now we can solve them using functions. After tonight, we'll be able to solve them using functions, and you'll understand scope. So as the problems get harder and harder, you will know how to approach them. So that is what we have coming up this week. So hopefully you can get a little bit excited about that. And so we do have slides. I pasted them in there. So let's pull them up. I don't have any LaCroix tonight. I just have a nice little glass of normal water, and it is a little bit weird. It's more refreshing, but it's not as fun. So that is something to take into account when you are choosing how you hydrate yourself. The water works well. Normal water works well. It does the job, but it's not as fun as LaCroix. So we're just gonna be a little bit boring tonight. Pretty good. Pretty good. Side note, so on Mondays, right before we start the streams, the people that I'm in the business bootcamp that I'm in a incubator cohort, and we do like a little a stand-up every week to kind of just talk about where we are and just catch up with each other, make sure we know what's going on. But we had a bunch of homework since our last session. We meet like every 2 months, like for the cohort. It was every month last year. It's like every 2 months now. And so we had a lot of homework, and I haven't had to do homework in so long, and it was a lot of homework, and we kind of all waited. We didn't wait till the last minute, but we waited until it was a little bit late for how much homework there was. And we all turned it in. We got the stuff in, but it was like right at the last minute, and they were going through, we were just talking because they were going through and they were grading it today. And you can only get 3 scores. You can only either get a 50 or 75 or 100. Basically, if you turned it in, you get a 50. If it satisfies everything, you get a 75, and if you went above and beyond, you get 100. And I only had time to like really give like 2 of the like 7 assignments like my all, like 100%, and everything else just got done. And it felt like school again to sit here and watching my phone and receive. I was getting 50s on things that I hadn't really tried on, and it really hurt. So I was a little bit down before we started this, but I was just thinking back. I just saw it when we were in the show my Google class. I mean the drive stuff. I saw some of the work and I was like, man, that hurt. So I'm gonna have to learn how to be back in school mode now, because now that they're grading assignments, I wasn't ready for that at all. At all. It kind of hurt. I didn't expect it to hurt, but it definitely hurt when you have to put in a bunch of energy. But okay, story time's over. Let's go ahead and talk about functions, lambdas, and scope. Every time I write the word lambdas and every time I see it, it always looks spelled wrong, but it is in fact spelled right. How do I know it's spelled right? I know it's spelled right because there's no squiggly line under it when I'm not presenting. And you know, I could Google it as well. But pack and reuse, again, I told you guys I just throw taglines in there because it's exciting. Never know if they're really gonna work, but sure. All right. What is a function? Again, functions, this is something that you do need, like functions are very, very important. So a function is a block of code which only runs when it is called. So break that first part off. And maybe I should have put a bullet there to show that this wasn't one long running thing. This is the first piece. The second piece. So actually, let's break that down first. So it's a block of code. So it's a section of code and it only runs when called. So we know right now when we write some code and we, you know, pass it to Python, we tell Python to run it. The Python interprets this code and it goes down the file and it reads the lines and it executes the codes. The only thing right now that it skips is the comments. So this is a function block that's only going to run when we call it. So it's not going to run by default. You can pass data known as parameters into a function. So function is a block of code and you can pass information into that block of code when you run it. Let's talk about how to do that. And then a function can return data as a result. So something can go into a function, get passed into a function, and then something can come out of a function. That is very, very important. Something goes in, something comes out. Nothing has to go in. It's not a requirement that anything goes in. It's also not a requirement that anything comes out. And so let's take a look at that. So how do we create a function? We talked about functions, this block of code that information can get passed into. That's commonly the term people say, hey, would you pass into the function? So I use the verb pass, but we can pass data in, get stuff out. How do we create it? In Python, we use the def keyword. So in different languages, it's different. For like, again, if you watch the DevOps course, when we did Golang, it was func. There's other languages where it's function. Other languages like Ruby, it's also def. And Python will use the def keyword to define a function. Again, that's how you can think about it. Def for define. First was it Mr. Mars or MX Mars. Thank you for the follow. And AJ Bear, welcome to the channel. Thank you for the follow. So we define a function with the def keyword. So also when you see parentheses, think function. Most of the time, it's not always true, but when you start to see parentheses, you kind of know something is a function, and we're gonna look at that. And this is just an example here. So it's def to say, hey, I'm starting a function. You give the function a name, and then you put parentheses after it to let Python know that this is a function. So let's go ahead and let's create our first function. We're gonna hop right into, let's clear this. Let's go back. Where am I? I'm taking the long way. Streams, Python. Okay, we'll say here, we'll make their functions, and we really need to clean this up. We'll do this at the end. Make their functions, and we'll cd in the functions, and we will create first func.py. All right, so we opened up a new file called first func.py. You can see the name down here, and let's define our first function. So how do we create a function? We use that def keyword to define the function. Type in def if, oh no, my server is not working how I want it to. Oh, that's not a server problem. Hold on. Oh, that was dumb. See, you guys caught me there. You saw a brain fart. That was a huge brain fart. What editor are we using? We talked about those editor wars. You know that Vim is a modal editor. I know that Vim is a modal editor, and I was trying to type and nothing was happening. And that's because I did not go into insert mode. That's because it's late. I don't know why that happened. Well, I don't know why I did that. I know better. So type it in now, and we type in def. All right, so you see def, it turns red. My editor is set up to know how to do this. If you are using VS Code, it will also probably give you a color. It might actually even open, like fill it all out for you. Might actually all fill it out for you. So def, and let's take a look back. It's okay to look back at our notes, and def to define the function. So Python now knows, like, all right, we're setting up a function here. And then you type in the function name. So you can give it any name you want. I think in Python, there are rules to naming these. I think it has to be lowercase. I think uppercase, it may be uppercase. We'll test it. That might be for passing functions around or something. We'll see. Might have to be uppercase to export. We'll check that out. I'm not actually 100% sure. But so we're gonna call this our func. You can call it whatever you want, but actually we'll just call this def. What is it gonna do? We're gonna go back and do a hello world. So we'll call this function hello world. Actually, I think it's better named something else. So we'll say our func is the name of the function. So we give our function a name. So again, this can be anything you want. This is like a variable. It's a variable name for your function. And then you need these parentheses here to make sure that Python knows it's a function. So you put the parentheses there, and we put the colon here so that to close off that statement. So this is how you define our first function. So this is a function. It does need something under it. So remember in the loop section, we had something called we had pass and continue. I think you can do like a pass here. It would not let us run this code right now if we didn't put anything underneath. So I think this will work, and we can run our code right now and see what happens. What do you think is gonna happen? We have a function here. All it's gonna do is pass. What do you think is gonna happen? Let's go ahead and run it. All right, nothing happens. It kicks us back to the command line. Nothing actually happens here. So what is the first thing we had on the slide back here? A function is a block of code which only returns when it is called. You haven't yet learned how to call a function. So it's likely, we knew we just created it, but it's likely we haven't called it yet, which we have not. So this pass actually didn't do anything. Like, it actually never ran this code here. It just opened up the file, interpreted it, and left out of it. There's nothing for it to do. So it gave us no output. That is okay. That is okay for you to do. I just had to put something here, because if I didn't put something here and I try to run it, it will give us an error because it's expecting, you set up a function, it's got to do something. You got to tell me what to do with it, even if I'm not going to run it. So cool. So we have our first function here, and this is a valid function. That is your very first function. Doesn't do anything, but it is a valid function. So let's go to the next thing. So we've learned now how to create a function. Very simple, but that's kind of useless. Like, creating it and having it pass is stupid. Doesn't really do anything. We also haven't even learned how to run it. So the next thing, how do we call this function? Functions can only run when they're called. How do we call a function? Pretty simple, actually. Functions run when they're called. How do you call a function? You simply call it by name, of course. I don't know why course is capital C there. There's a lot of inconsistencies with these slides. I know. I'm sorry. For anyone who has ADHD or not ADHD, what's the thing where you just, like, everything's got to be straight? OCD. I'm sorry about that. I'm not going to fix it. So you got to get used to it or get out of here. Psych, nah, stick around. I'm joking. But yeah, so you call it by name, of course. So let's change our code to do something different. So everything that is, you name a function and it's a block of code. And so when that function is called, it will run whatever block of code is in here. So let's make a simple hello world function. So how do we do hello world? We just print it out. So we're going to print hello world, exclamation point, and we are going to hit enter just like this. And I'll hit escape real quick. And again, just so you can understand what functions are, what happens when I run it. Actually, whoops, I didn't close this string. And when we run it, again, nothing happens, because again, we've defined a function, we've defined a valid function, but we have not called the function, so it does not run. So let's call a function. Again, we said we call it by name. Remember, Python is it's white space matters, and that's how it determines the ordering and what runs. So anything I type that's on the same level as print will actually be in this function. How do we type outside of this function? You backspace basically and make sure that it's on the same level as this. So calling our function is simply, what's the name of our function? The name of our function is rfunc. And again, to call it, actually, let's type that in. We say call it by name. So we called it by name, and let's save this and let's run this. And when we run it, I actually didn't think that was gonna work at all, but nothing happened again. Let's see why nothing happened again. This is very interesting. I actually thought this would fail, but we called rfunc, but to the computer, this is not anything right here. It's not the function that we've created. To call the function, you have to put the parentheses here to make sure the computer knows that it's a function. So this is what it will look like. If you want to call the function, you call it like this. So let's save this and let's run it. So you can see the output here, hello world. And just like that, we've created a function, a reusable piece of code, and we've called it. So we'll stop there for a second. Any questions on that so far? Yes, Afrocoder, the name of the function should be descriptive of what we're doing. So the description of this would be better suited as something like hello world. The reason why I did not call it hello world is because I've seen people get confused of when you name this something and are doing the same thing inside. They get confused about what's happening, and I wanted to be very, I wanted to make a clear distinction about what was doing what. So yes, you do want to get better. You don't want to name your function something like this. It should be descriptive of what is going on. How do you enable Vim colors? So if you do, maybe somebody gave it to you, but if you do, was it dot files? Maybe dot files or Vim settings. You can get my Vim RC file. So Vim, where is it on? Am I using NeoVim here? Let's see. Whoa, button modifier slash Vim. Not there. Let's go. .nvim. I actually don't know where my. I don't know where my ending.vim is. I can never remember which computers I'm using NeoVim on and which ones I'm using regular Vim. But if you check out my Vim file, I'm using a plugin. I'm using some Vim plugins. I'm using a fair amount of Vim plugins actually to get my stuff set up properly. Some distributions it'll come out by default. I think NeoVim actually does some, depending on your setup, some syntax highlighting by default. But check it out, see if you can figure it out. And again, actually, I promise you, I have a video coming out on how to get exactly set up the way that I have it, and to help you be able to explore and set up things on your own. The only reason I have not released that yet is because of a problem, again, that I was having with editing that ruined a middle of the video before I got my new graphics card, and I just haven't reshot the middle of that video. It's coming. I promise you, it's on its way. All right, but yes, VS Code would be easier for you to use most likely. I do recommend using VS Code. It'll give you stuff right out of the box. Like, actually, I can get out of here and I can code, and it'll give you some colors by default, which is nice. But yeah, we're gonna stay in Vim. We are gonna stay in Vim. All right, how would you run the function in the VS Code terminal? Great question, actually. That's good. Maybe I'll start doing more stuff in VS Code. I don't know, man. I'm just so much less proficient in here. I feel so lost, to be honest. But all right, so to run it here, you could do one of two things. So this is just a file that is open on our computer. I can actually still go back to my terminal, and as long as I'm where the file is, I can run it from here. I can absolutely run it from here. That is running the same thing. But if you're using VS Code, it's probably easier to hit Control tilde. So tilde is on most of your keyboards, it's going to be right under the escape key. It's a little squiggly line. It is, in fact, this character right here. So if you hold Control and hit tilde, and actually it sucks because on my keyboard I actually have to hit 4 buttons to do this. It opens up your terminal, even if you're on Windows, it opens it up where you currently are, the directory that you're currently in, and then you can basically type in Python run, and I think you can also do something like this. Yeah, you can do that as well. You can just hit this little play button up here. I never do that, but you can do that. So that's pretty cool, and that's good to tell people actually, so that they don't have to worry about messing with their command line stuff. That's actually really good. And it knew to pick up everything and knew how to call this entire file by name. That's really cool. All right, VS Code. I mean, I've always loved VS Code. VS Code is great. That's why I recommend it. But we're still gonna use Vim. Sorry, it's okay. All right. So call our function by name. Now we say that functions are reusable pieces of code. What do we mean by that? How is this a reusable piece of code? It's because now we can call this again and again, and we can print out. I was going to print out the function, but I don't. That's dumb. So we can print out and again, and then we can run our function again. All right, so let's look at this. We run our function once. It's gonna call this function up here. It's gonna print out hello world. We call it again. We're gonna print out hello world. Call it again. It's gonna print out hello world. It's gonna print and again. We call it again. It's gonna print out hello world. So this code is going to run every time it is called. So, whoops, I did not mean to do that, but I'll just press play because we're here. And you can see here, hello world, hello world, hello world, and again, hello world. So now you learned that loops were a way to execute a block of code multiple times, which is great. Sometimes you do want to do that, but you don't always want to do that. Sometimes you need to execute code at different places in your application. So writing code and packaging up bits of functionality in functions can allow you to use this code at different pieces of your application very easily. So remember, we also said things like when you see these parentheses thing function, like this print right here, print is a function, just like this one that we've defined ourselves. Print is a function in the Python standard library, and it has some code underneath it that says do a bunch of stuff. And it gives us the functionality that we need. So the same way that we use print is how we can use our functions that we create throughout our code. So again, a function is just a packaged up block of code that only runs when it's called. And how do you call it? You call it by name, of course. All right. Pretty, I'm hoping that's understandable. We're about to do a lot of stuff with functions in a second. I'm gonna do a whole lot of stuff with the functions in a second. But yes, any questions there? I didn't get any questions before we went to that piece, but again, you can run it multiple times, and the way that you call a function is by name, and you have to call it by name with the parentheses. All right. So, next things, we're making great time. Function arguments. We talked about you being able to pass in arguments. You can pass data into a function. These things that you pass in are called arguments. If you watch the DevOps one, this is the same. This is very similar to the arguments that the command line arguments as you pass in. These are positional as well. These are not positional. Sorry, these are not positional. You can pass in multiple arguments by separating them with a comma. So we can pass in arguments, but we can also have multiple ones that we pass in. However, many arguments are in the function. However many arguments are in the function, not however, comma many. However many arguments are in the function definition must be passed in when calling the function. So what does that mean? A lot of words there. That simply means that in the function, what's a function definition? A function definition is simply where the function is created at. So wherever this function is created at, however many arguments they set up for you to pass in, you have to pass in that many arguments for the code to run. And let's do that. Cool. So let's go ahead and set up. Let's actually leave this here and let's rename that. Move first func to, let me create func. It's a little more descriptive of what that file is. And let's make one now called func arguments. Arguments dot py. All right. So functional arguments. A good option for this is named arguments and default parameters. Probably. I wasn't going over them, but I think there'll be more than enough time, and I think it is worth. And I think they're both worth going over. I think that's okay. Yeah, sure. We can actually do. We should be able to do that right now during this one. So let's go. A simple thing like maybe you want a function that's going to simply add two numbers together. This is a common one to kind of go with first. But let's say we want a function. How do we define a function? Again, let's practice. And that is with def. So that's the name of our function. And maybe our function is going to be called add. We just call it add, but actually just leave it at add. So func def add. I don't think add is a reserved keyword, but we're gonna find out in a second. Def add. So we now have a function that is called add. And what it's gonna do is it's gonna take two numbers and it's gonna add them together. So let's actually put a comment here. Add function should take two numbers, comma, add them together and print out the sum. All right, so that's what our function is going to do. It's going to take two numbers, add together. How do we pass in data? You pass in data basically inside the parentheses. So you basically set variables as kind of placeholders to be passed into a function. So we want to pass in two things. We can call these whatever we want. So we could call it like X and Y. So one thing would just to show you like how things work. Let's say def add X. Actually, just so we're not confused, let's make another one really quick, just showing one parameter before I do multiple parameters. Let's do def, and we're gonna say, this one's gonna be called echo. So we're gonna create a function that echoes whatever we pass to it. So we're gonna say echo, and we're gonna pass in X basically. And again, X is just a placeholder for anything that we pass in. This just says, hey, you take one argument. What's up? I am Vazu. Thank you for the follow. What's up? Baskin B. Thank you for the follow. Welcome to the channel for both of you. So we're gonna make a function that just echoes out what we're gonna say. And so we're gonna do print X. So let's follow this logic really quick. We made a function called echo. It takes in something. It takes in X. It just takes in one argument. So when you pass that argument in, all that's gonna happen is it's gonna run print and it's gonna print that argument. Again, this is just a variable and we can reference that variable down here. It's basically defining a variable and we can reference it down here. So how do we actually pass that data? So we've set up the function to accept an argument. How do we pass that argument in? And we hit you with the echo. And again, you need to parentheses, so that would call the function echo. And let's run this first. So we defined echo that takes in one parameter and we're gonna print that parameter out. Now we've defined the function, now we're calling that function and we're calling echo. So let's see what happens when we run this. Oops, what do we call this file? Python 3. All right, so it looks like we have a problem. What's that problem? Let's read what it has here. It has a traceback. It says type error, echo, missing one required positional argument, X. Excellent. So remember what I said here. Last line, however many arguments are in the function definition must, in all capital letters, be passed in when calling the function. So that function definition, this function definition, this is the function definition right here, because this is where we define the function. It takes in one parameter, or one argument, and we did not give it an argument. So let's go ahead and give it an argument. The same way that we tell it it's going to take an argument, we pass it in here. So we're going to say, we're just going to pass in our name. And so this will take, by default, this will take anything. So we're going to pass in our name first. And so basically when this gets passed in, it'll pass in Aaron as X. So now X will be equal to the value of Aaron, and we're going to print out X, which should print Aaron. Let's do that. When we run it, we do in fact get Aaron. So let's run it again. Let's change some stuff up. Let's try some different data types really quick. What about, we did a string, so let's do an integer. So pass in 5. Let's see what happens when we pass in an integer. And it does in fact print 5. Let's do 5.5 really quick. And actually let's do them all in the 5.5. Let's do, again, because you can use it, you can call this code more than once. Let's do like false. And that is everything that we need for now. Actually, let's also do like a struct, like some kind of data structure. So let's just do a list of like first name, last name. So like Aaron, comma, Brooks. Okay, now let's go. So we're gonna try to, we're using this function 3 separate times. So these are all 3 different instances of this function. Right here, we're gonna be passing in what kind of data type is this? This is a float. Excellent. Right here we have false, which is a Boolean type. So that's important to know. And then we have a list here, and I need to close it. It looks like Easy Goodness caught it. Thank you for that. Let's close that up. So 3 different times. Let's see how it handles these 3 different things. And we run it and it prints those things out. No problem. It doesn't have a problem at all. Again, this is another thing that's kind of good about an interpreted dynamically typed language. It can kind of do that. So in things that are statically typed, I would have to tell it what type is getting passed in here. I would say X is getting passed in, and it has to be a string. This is why it's kind of cool. You can kind of just print out whatever you want here. So that's how you take a single argument. Any questions on that before we move on to multiple arguments? And what's up, Zooksby? Zooksby09, welcome to the channel. Thank you for the follow. Cool. So that's how you do single parameters. So let's put that in here as a pass single parameter into and a function. Also, just to show you that like this could literally be anything. I'll change what was getting passed into something like our argument. And if I try to run it like this, what do you think is going to happen? So we're going to pass in a placeholder of our argument. We're going to print X. Let's see what happens when we run this. It does nothing because it says X is name, X is not defined. And again, once we put that argument in here, it basically defines a variable for you. So right here, X is not defined. Just down here, we need to change it to whatever is up here. If we want to reference what's passed in, whatever's up here, we need to use the same name. So this is just a variable. So we have our argument. So this will still work. The same way that X worked, this will still work. That is important to know. I think that was something that weirded me out the first time. Like I for some reason, I think my mind wasn't making the connection that this was just a variable up here, and it complicated it. Like because I knew that you could create a variable, but I didn't see you creating a variable anywhere, so I got a little confused. But when you pass in this argument, you're basically just setting a placeholder for whatever that thing's going to be, and it gives you a way to reference it later on in your code down below. So great, that's how you pass in one thing. So let's go ahead and comment all this stuff out. And let's go back up here. And I don't know why I did. That was the slowest way possible. So we want to add in multiple arguments now. So if we want to add two numbers together, we obviously need two numbers to be passed in. So we're going to do comma y. So we'll do x comma y. And again, these are variables. We can call them whatever we want. It just means that when the position does matter. So if x is first, whatever number we pass in first needs to be right here for it to be set equal to x, and y accordingly. Cool. So if we want to add these things together, how do you add two things together in Python? You can simply do x plus y. So we said here, add function should take two numbers, add them together, and print out the sum. So right now, just reading that, we added them together, but we are not printing out the sum. A couple options for that. We could just print this. You can print this, or we can mess around, and that's the best way to do it. That's the way that I would do it. But again, just to make it a little more, we'll get a little more explicit. We'll create a variable called sum, and we'll set it equal to x plus y, and then we'll print out sum, just to make it, again, a little more explicit, and so we can just practice writing more code and, I don't know, just having a little fun. So we have a function here. It takes two numbers. So how do we tell it to take two numbers? We can add more than one option inside the parentheses separated by a comma. And again, that's reference right here. You can pass in multiple arguments by separating them with a comma. So we just did that. And let's go ahead and let's run this code. And again, I wanted you to see, I'm sure a lot of you probably are starting to catch it now, that although we created this code, functions must be called, and they must be called by name. Let's go ahead and call our function here. Add. All right, let's run this. And it doesn't work. And again, I'm sure many of you are catching it now, but it says add. Missing two required positional arguments, x and y. And again, why is that? That is because we, in fact, did not pass in an x and a y. How do we do that? Right inside of the parentheses. So first number we're going to do is 709. Whoops, wrong spot. 709. 7098. I got fat fingers. I typed it out that way. Let's go ahead and make this a nice even number. We want to add them together. Let's go ahead and add two. This should give us a nice and even 7100. 7098 plus 2 should give us 7100. So let's see what happens when we pass in these two things. We separated them by a comma up here. We also have to separate them by a comma down here. So that is pretty consistent across the board, which is nice. Run it. We get a nice even 7100. But yeah, we pass in two numbers and it added together. If you didn't know math, you can do it the opposite way and it'll still equal the same number. 7098, we'll do that. We'll do add. What's gonna happen, actually, what's gonna happen if we don't pass in a number? What if we add in like the string of 5 and the string of 6? What's also gonna happen, well, we'll leave that here for now. So let's run this. And we run it, we get 7100, 7100, because all we did was flip it around. And then we get 56. We, again, just harping back to the things that we've learned so far. Even though this says add, and you might automatically be thinking numbers, remember, in Python, we can add strings together. We can concatenate strings. Concatenating strings is, the process of combining strings together end to end. And we can do that with the addition sign in Python. So it was able to concatenate those strings. So we can't add those things together. But again, it's very specifically because this is an add function. If we made this a subtraction function, this would fail. It does the first two numbers, and then it fails, and it fails because not all arithmetic operations can be done to strings. Minus is one of them. but we can go back to plus because this one's called add. And so let's make it plus again. Let's remove the string. Actually, let's leave this here. Let's give it 2 other numbers, bigger numbers. And let's add in some other things here. Actually, I didn't do that. Let's see. So our argument is a parameter. Yes, down here, if you're still referring to this, our argument is absolutely a parameter that is being passed in, yes. In this case, the arguments are X and Y. You got it. The arguments are X and Y in this case. So let's do the same thing. Let's do add. Let's do def. Let's create a new function. So when you saw me type def, you know that that's a new function definition that I'm creating. So brand new function, and we're gonna call this one subtract. And this is also gonna take 2 numbers, and we're still gonna call these X and Y. And I think this is important for you to see as well. Whoa, how do I redo? Well, all right. Def subtract X comma Y. You haven't learned about scope yet, but you will. But this is your first kind of foray into scope a little bit. This will lead into the scope conversation we're gonna have in a little bit. But what if we did the same thing here? And does anyone know the name of when you subtract 2 numbers, what's it called? The difference. That was dumb. I definitely knew that. So difference. So the difference is going to be X minus Y. All right, so we do have 2 functions here, and let's go ahead and print that. Print difference. All right, so we do have this here. So we have a function that adds, and we have a function that subtracts. Right now, we are only calling the add function by name. Let's go ahead and call the subtract function instead here. Just change the name to subtract so you can have multiple functions in the same file. Yes, again, because that code only executes when you call it. Excuse me. So we're gonna add these 2 things together, and then we're gonna subtract this thing down here. And let's take a look at this. Maybe we'll make those numbers smaller so that you know they're working right. Let's make it a little easier so you know that it's subtracted properly. 10, and we're going to subtract 5 from it. Nice and easy, so it should give us 5 back. All right, 7100, 7100, and 5. Great. What's up, Duke Nukem? We're learning about functions, lambdas, and scope tonight. So yeah, we're learning about functions tonight in Python. So I use X and Y here, and we know, variables. We know about variables, and X gets set to whatever we passed in. So you might think that when you run through this, that all right, right here we passed in X as 7098, and then we passed in Y as 2. So now X equals 7098 and Y equals 2. And then maybe you think, oh, because we ran add again, now X is 2, and now Y is 7098, because we know that we can reassign variables. This is a common flow that I've seen people struggle through. And yes, like that does seem correct. But then when we do subtract, we are assigning X to be 10, X to be 10, and 5 to be 10. 5 to be Y to be 5, and you would say, all right, well now those are equal to this, and actually I probably need to put another thing in here to kind of really like make the point that I'm trying to make about it being confusing. But you can in fact use the same variables in between each function, and this is because of something called scope, which we're about to hop into. But these variables are only scoped to this function. So think about your Call of Duty days, think about your Halo days, playing games, think about, working on a project, and people might say, hey, what's the scope of this project? What all does it entail? These variables are they only live in this scope. So they don't actually exist outside of this function. So X and Y here are different from the X and Y that are here in subtract. And that is your first foray into scope. We're gonna dive way deeper, but just wanted to get your mind thinking around that, so that you're not thinking that these X and Y's reference the same thing. But again, it's common that that you probably wouldn't have these be the same. You can call it whatever, just so we're not confused. Num1 and num2, while they're X and Y up top. No big deal, we just have to change these as well. Num1 and num2. And again, you can use these variables as many times as you want throughout the code that exists in here. This code could be much, much, much longer. So cool. That is how you pass in 2 parameters. And could it be 3? Absolutely. It could absolutely be 3. X, Y, Z. And we'll still leave num1 and num2. But again, because we added a new parameter, a new argument, we need to add in a new number. So we'll do 7. And right here, we will do 10. So now we're passing in 3 things here because we need an X, a Y, and a Z. Let's do something with that Z really quick, even though that code will probably still run. All right, so we're gonna add X, Y, and Z together. We're passing 3 things in here. And we run it and we get 7107 and 7110 because it added all 3 numbers together. So again, you can pass in a lot. You can pass in lots of things, really as many things as you want, but yeah, cool. Any questions about that so far? So what do we learn so far? We learned what functions are. Again, a block of code, a reusable block of code that only runs when it's called. So it will only get interpreted when you call it. How do you call it? You call it by name with parentheses after it. We also learned that you can pass data into it. So it's something you can pass data into, and that data is called an argument. So you pass in arguments. How do you pass in arguments? You pass them into the parentheses. You create them in the function definition. You create a variable for them in the function definition, and then you pass them in the parentheses when you're calling the function by name, of course. And we also learned that you can add multiple arguments, multiple parameters that you can use. And how do you do that? You separate them with a comma. And we learned that you must call the function with the same amount of arguments in which it was defined with. There are ways to pass in, like null data or 0 values. If you don't have something you need for that, but you must call it with the same amount of things. So cool. Get a little water, and then we're gonna go into next piece. Good on time. We're making good on time. Okay. Now, I meant to change this, but I guess this is just a good meme, a good GIF in general. But getting information back. So when calling a function, we're usually passing in some data to be processed and looking to get some type of output, which we've seen so far. We've printed some output. In order to use this output outside of the scope of the function, to be able to use this output, like when data gets returned, in order to use it, we actually must return it if we want to use that data. We must return it from the function, and return is capitalized because it is a powerful keyword, a keyword that you're going to need here. Multiple values can be returned. This can be confusing. What does any of this mean? You just saw us run functions and we were able to see information and get information back. What does that mean? Let's copy this just so people can know what to do. Let's copy this file to func_returns.py. All right. And we're gonna edit this file. So right now we're printing out things. So let's say we set up sum here. Let's say we did not print it here. And let's also say we did not print differences here. We could, let's run this code first. And we run it, but what happened? Why did it actually, did I save this? Oh, because I ran the same, that was dumb. I ran the same file. I forgot to copy the file. Python 3. I don't know who just followed, but I'll see your name in a second. Oh, Shanda, what's up, Shanda? I talked about us. I talked about us in the beginning and our struggles with our homework. But thanks for subscribing. Welcome. Thanks for tuning in. So Python 3. What do we call this one? We called this one func returns. All right, so we ran this one. We ran the func returns, and we got nothing. We got no output, and we got no output because we did not print anything. For one, that's why we got no output to the screen. But I didn't tell you this, but you can set the value. Like basically, you can create a variable. So I create a variable called, our number 1, and I can set it to the value of this function. So basically what it'll do is it will evaluate this function right here, and then it will set that value, whatever it gets back, it will set it equal to the variable our number 1. So this is something you can do. You'll use functions for this a lot. And so let's go our number 2 equals, and our number 3 equals. So we got the 3 of the things here. We're setting them to the values of our number 1, our number 2, our number 3. So after we set it to those values, let's see if we can print these. We weren't using a print before, but let's print all these out now. So our number 1, let's copy that. 2 and 3. So we are going to run these functions, and we're going to set them to these variables, and then we're going to print out those variables here. So go ahead and see what happens when we do just that. And when we do that, we get none, none, and none. 3 nuns, 3 none types. Very exciting. But why are we getting 3 none types here when we knew before? We saw when we ran it up here, we were getting some dope output. Everything was great. Everything was looking good. Why are we getting 3 nuns right now? We're getting 3 nuns because before, when we ran these things, we had print statements in the function. So when it got to that line, it would execute that code. This code is in fact executing. It's running. All right. It is in fact running. This is happening. Sum is getting set to these 3 things. They're getting passed in. It's running these things. But again, we talked about scope just a little bit, but we are not able to use the values of these things because this sum variable only exists right here. Like when it does this addition, it only lives inside of this little block of code that we kind of have here. Same thing for subtract. So how do we use this data? How can we access this data? And we do it with the return keyword. So we simply return something. You can return something. So here we're going to return sum. That's what we care about. You can return whatever you want. Return keyword is how you do that. And so down here, we're going to do the same thing. So this time, the data that we care about from this is we want to return. And you can see return is like a nice keyword. It turns red here. Super nice. And we're going to return difference. So return sum here. We return difference here. So let's hit escape. Let's run it. And now we get what we are supposed to get. We now see that it did that. Again, functions are great. And you can almost like, for right now, think about it like this. It's the block of code, it's a little block of code. And pretty much every time you use that block of code, you're going to pass data into it. It's going to do some processing and then it's going to spit out something. So to get that, you need some arguments up here, and to pass in data, you need the arguments. To get data back, you need this return statement. And that is honestly, like, this is the core thing. This is the core thing that you do in programming. Like almost everything you're going to be doing is taking in data, using it to modify some things, make some decisions, transform it, whatever, do a little bit of processing and spit some data out. That is essentially what you're always doing. It is, for the most part, that simple. So hopefully that makes it a little more approachable to be able to hop into some of this stuff. And so again, that return keyword is how you get that data out, and you can only have a single return. Well, you can only have one return execute. I could have multiple returns in here if I was using something like an if statement. I mean, yeah, you could, but only one can execute at a time, or only one can execute for this function to work. A single return statement here. But what I could do is we can take in multiple values. You can also return multiple values as well. So maybe I want to take this up here, and let's actually just copy. Let's copy all of this. Ink it, and oh, made mistakes. Mistakes have been made. All right, there we go. Mistakes have been made again. What am I trying to do? There we go. Comment this stuff out here. And let's go down to line 17. Whoa, why did it not yank what I wanted? That's annoying. Actually, let's get out of here. I'm not gonna save this. Let's simply just print these out instead, especially because this is wrong. So it takes in three things here. Let's do this. It's going to take in X, Y, and Z. And it's going to return X, comma, Y, and Z. Let's take a look and see what this looks like. Let's comment this out really quick, so you can just see what happens when we do something like this. X, Y, and Z. What are we doing? Def add. These are both using add, so I'll use those, and I'll comment that out. All right, let's save it. Let's save that bad boy, and we run it, and we get this. We get this tuple of things. Here we get 798 2 7 2 798 10. This is what was passed in. So we did return those multiple values. They got set to the values that we had in that file. So you can return multiple things if you want. So you could also have something like this. We could do add. We could have a function that's called add and subtract, which returns multiple things. So maybe add and subtract. Maybe it does add. So maybe it does add first nums equals X plus Y. So maybe the first thing this function does is it adds the first two numbers, and then it subtract last num. So maybe it does those, maybe it adds the first two together, and then it, subtracts the last num from the second num, or last two nums. This is dumb. This is a dumb function. It's a very stupid function, but it is a function nonetheless that we can return two values with. So maybe when we pass these in, maybe we get a variable called add first nums, and it adds the first two numbers, which is X and Y. And then it creates a variable called subtract last two nums, which subtracts Y and Z. And we can return those two things. The amount of returns does not need to be equal to the number of arguments that were passed in. So we can return add first nums, and we can return subtract last two nums. So this is dumb again, but I can, evaluate these things, and I can return both of those things. And when we see it and we run it, no, I can't. Why can't I? It said invalid syntax. Again, the same way that we do, that we pass in multiple arguments is the same way that we have to return multiple arguments. And that is simply with a comma. And you will make that mistake a lot, as I do as well. Let's see. Add is not defined. Oh, okay. So it gives us another error. It says name add is not defined. Let's see if we can figure out what this is. It says line 10, add. And this worked before, but let's see why it doesn't work. Let's troubleshoot what happened. This add is not defined. So where do we see add? Is add available anywhere? We can see in the error that it gave that we're calling the add function. But if we look for an add function definition, there is no add function definition because we changed the name of our function. So we also need to call the function by name. Again, function needs to be called by name. So if you want to call it, got to call it by the right name. And we need to go ahead and do that. What are we doing currently? All good. What's up, D-Flare? We are learning about functions, lambdas, and scope tonight in Python. So we're just learning about functions and how you can pass in arguments and return data. Right now, we're specifically talking about returning data from a function. Change that to, whoa. What's happening here? I'm making all types of mistakes. It should, I'm lazy. I don't like to type out things that I don't need to because I'm still not great with this keyboard. And I'm also a pretty bad touch typist. Add and subtract. Oh, wow. I always do stuff like this and I don't know how I just did that, but it's all good. Wow, undo. Man, your boy is having the time of his life. All right. So now we're calling the right function. So the only function that we have in this file that is not commented out is this add and subtract function. And right here, we are calling the add and subtract function. So this should fix our problems. And when we run it, we get two things back. We've returned two things. We've returned the two first numbers added together, and then we've returned the second two numbers subtracted from each other. So again, all that was to show you is that you can return information from a function, and that is the only way that you can use that data, use any information that's calculated in a function outside of the scope of that function. That statement will make more sense when we go over scope. But if you want to use the information that you've created or processed in the function, you must return that data if you want to use it. Obviously, again, you can use print to just see it, but to get it and to use it later on, you need to return it. Cool. That is how you get information back. So let's share again. Any question on returns and getting information back before we go on to lambdas, which is going to be conceptually it's the same thing that we just learned with a few parameters around it. But the syntax is probably going to throw people for a loop a little bit. I know I like them, but some people get a little confused there. Let's see here. Can you call a function in itself? Yes, you can call a function in itself. It is called recursion, and there's some interesting caveats to that. Let's mess around really quick. Great question. I like that question. Huh? Yeah, I'm not about to teach recursion, but you can. What was our first funk? What's the first one we did? Them create funk. What we did? Hello world. I actually don't know if I don't know how recursion works in Python by default, if I can just do it or not, but let's try. So let's print out hello world, and let's try. Yeah, I don't know if it just works out of the box with this or not. Whoops, what am I doing? Struggling. That's what I'm doing. Struggling. And let's put in hello world here again. And if we run this, take 0 positional print. Oh, I gave it, that was dumb. I gave it a I gave it a parameter. So it also works. So you have to pass an exact amount. So if you give it a parameter when it doesn't take one, which this one does not take a parameter, it failed. And when I run, check that out. You basically get into an interesting infinite loop until it gets down here. Not an infinite loop, but yeah, a maximum recursion depth exceeded. So yes, that is called recursion. Great question. You can, in fact, call a function inside of another function. There are times when you have to do this. Well, I've never found a time when I had to do it in real life, but there are times where you have to do it to solve coding challenges, which is interesting. But it absolutely is a thing that we probably won't cover much recursion here. But yeah, you can call a function inside of itself. The recursion is, oh yeah, yep, so many seg faults, absolutely. Blue screen, like, yes. Recursion, the first time I found out about recursion, I was like, oh no, this introduces way too much complexity for me. Like, I don't like that I can call, it felt to me, it felt like I shouldn't be able to call this function when I just defined it here. Like, in my mind, for some reason, this shouldn't know that this exists, but it does, so. Yeah, recursion does make things easier. It can make things easier. I've seen situations where people have thought to use recursion, but did not use recursion because it can be difficult. Recursion can be very difficult to troubleshoot when there are issues. And so I've seen a lot of people try to stay away, but I've never seen it used. Like, again, I'm also not a software engineer. I'm a DevOps engineer, and things that I'm generally dealing with are, infrastructure, things like that. So maybe now that I'm, more heavily on the application side of things, maybe I'll start to see it more. But never mentally something that I go to for sure. Traverse large structured data. Again, I feel like, and again, for my job, I've never had to do that on the job. I've only had to do it for solving coding challenges. So yeah, maybe I'll look for a place in my current position where recursion would work out great. All right, cool. So that was an excellent question. Who asked that? Afrocoder, thank you for that question. Always great to introduce new topics, because again, there are topics galore in programming, and we are just doing the intro stuff, so we'll miss out on a lot of things like that. So good question. All right, what are we doing next? 9:12. All right, we're still making good time. Lambdas. Let's talk about lambdas a bit. Lambdas are anonymous functions in Python. What are anonymous functions? They are functions with no name. They are a function without a name. That's why they call them anonymous functions. I always find this very interesting because the function itself doesn't have a name, but it ends up getting a name because it's assigned to a variable, but all good. It uses the lambda keyword instead of def to define itself. The syntax for this is going to be kind of confusing to you, but I thought it was good to introduce here. Anyway, you do not need you don't need to use these. There are times when it is better to use these, but they're not a necessary piece of programming. You can do everything without using lambdas, but again, it works. The function can have any number of arguments. So like, these are functions. These are anonymous functions, but they have their own caveats. There are things that are specific to lambdas. And again, this function can have any number of arguments. So we still have arguments here, but only one expression. So it can only do one bit of logic, which is evaluated and returned. So this can only have one. This can only have one thing that is expressed and returned to you. Lambda arguments. So this is kind of how it's set up. You set it equal to a variable. So I probably should have put a variable over here, and maybe I can do that, but I think that'll take it to a new line. So I'm gonna do x equals lambda, your arguments, and the expression. Is lambda a Python thing? No. I think they're only called lambdas in Python, I think. But also, like, JavaScript has like arrow functions, which are basically lambdas, kinda. Let's see. Well, let's learn about Python once first. Yeah, I don't think it's only a Python thing. I think other languages have this kind of syntactic sugar for you to be able to quickly create a function. So vim lambda.py. All right, so the way we did the add function before, is this where AWS Lambda come from? Oh, maybe that is possibly. I never thought about that. I don't know why I never thought about that. Maybe it's a concise function, which is exactly what AWS Lambda is, and that makes sense. But I can't be sure. But all signs point to yes. So we'll go with that. That's a great question. I feel like that was a soft, like you just tossed that up to me to hit out the park, but I don't know. I definitely don't know, but it will make sense. So probably, that's probably where it came from. But you know, Amazon, they do a lot of weird stuff, so it could be something way deeper that I don't know about. But yeah, sometimes aren't exactly known for creativity. That's true. That's absolutely true. All right, so let's see. Like that add function was like def, add, takes in two things, comma, I don't know why I did ZY instead of XY. That was just a mistake. And we did basically return. Oh, it's also important to know that you can do the expression in the return statement if you want. So I can like do this. I can return Z plus Y, and this will work. You don't have to set it to a variable. I can return just those things, and I can, run add for and 5, which should be 9, and we save it, and we Python 3 Lambda. And again, it doesn't print. Why doesn't it print? It doesn't print because we didn't do, even though we returned it, we didn't tell it to print anywhere. So it ran, and this worked properly. But you can actually print out the evaluation of a function. I can just put it inside of this print function, and it'll run add, and it'll print out the value. And so we get 9. So it adds those two things together. So that's one way you could do this. But another way you could do an anonymous function. So again, anonymous functions use the lambda keyword instead of def. They have no name. They have no name, which is interesting. So a lambda looks like this. You have to set it equal to a variable if you want to use it. Well, I don't think you have to. I think there are ways you cannot do that, but generally they're going to be set easy. They're going to be set to a variable, and lambda is the keyword. So you can see it turns red. As soon as I hit a keyword, it turns red. So lambda, and then your arguments. So x, comma y. I think it's a comma. It might be a space for this, but we'll see. X, comma y. The arguments that I want to create with this function. So lambda says, think about lambda in place of def. And again, this function has no name, so I don't give it a name. So there's no add here. And I pass in my parameters, which is x and y. And and I make it evaluate something which is returned. So you do a colon, like same thing kind of you have here. And then you do this all in one line here. And I can say basically do x plus y here. And so let's try that instead. So instead of, now our function looks like this because the function is assigned to the value x. And we'll do x. And what do we do? Same numbers, 4, 5. And we call x instead of this. And let's go ahead and comment this out. So I know this can be confusing. Again, it's syntactic sugar. Lambda, it doesn't get a name because it is lambda in place of def. It doesn't get a name because it's an anonymous function. And then it gets the parameter. So I could just do x. I could just do one parameter. This is 2 parameters here. And then it's going to evaluate them and return that. So let's save it. Let's run it. And we still get 9. So this is the way that you do it. So you can kind of one line a lot of these things. And again, not necessary, but nice syntactic sugar. What's up, Vilco? Welcome. Thank you for the follow. So yeah, this is what we got here. And so you could also do the same thing with, like, if you want to do like one of those hello world lambdas, it will look like this. we would say, hey, give me a function, this lambda keyword, think about a function, say, go ahead and give me a function that when it takes in one argument that I'm assigning to the value of X, and then it just returns X. So whatever comes after the colon is the evaluation point, and it evaluates that and returns it. So you don't need a return keyword because it's going to do it by default. It's kind of coded in there. So this won't work. Why won't this work? It won't work because now we're only taking in a single argument and we're passing in two. So let's run this. It will fail. It takes one positional argument, but two were given. Makes sense. Again, it takes only one. And so we can pass in just one. And this is like that echo one that we created. We'll pass in one thing, run it, it goes ahead and it returns it for us. So lambdas are cool for that. Again, it is, I don't know any other reason to use it besides syntactic sugar, and to kind of make your code a little bit cleaner in certain places. I don't know. So if anyone knows, definitely, if anyone has a good use case for it, over a function, besides, again, that syntactic sugar for a little bit easier, it's debatable whether or not it's more readable or not. You know, I could understand the argument for both. What if you have multiple functions that take an argument and returns one? What if you have multiple functions that take an argument and returns one? I don't know what that means. Which one has priority? Not sure I understand. So you always use a lambda and never use def to save time. Maybe. Again, this only evaluates, you can only have one expression here. A function allows you to have multiple expressions. There's a lot of processing that can happen. These can only do one expression. You could make it really long if you wanted, but it can only do one. Require multiple lines. Yeah. Am I thinking about lambda wrong? Can you do another example? Yes, I can do another example. So maybe, I don't know. I can do first name. So let's pass in first name, and last name. So we have a function now. Basically we have a lambda that's, you know, with no name as a function that takes in two parameters, first name and last name. And we'll write the regular, let's go ahead and write the regular function along with it. So we have a def, we got to give it a name. So we'll call it first, last, and it takes two things. It takes first name and it takes last name. So right now, these are essentially the same functions. Let's separate them a lot. So this is how you would write one in a normal function. This is how you write in a lambda. So with that first name and last name, what we're going to do is we're going to use that information to build a string that says, your first name is, oh, I wonder if I can do this. I probably can't because it's a print, but it's not a print. But let's say your first name is first name, and your last name is last name. Oh, it's gonna take it 2 new lines. Annoying. And let's close quote this. All right, so basically it's a function that takes in first name, takes in last name, and it's gonna evaluate this statement here. So the code that it's gonna run, so this part over here is just like this. And when you call it by name, it's gonna run the code that's underneath, which will basically be this code right here. So let's go ahead and put it together. Let's put it in the line. Oh, undo. Paste it. Undo. New line. Backup. O, P. No, P. All right. So it's just like this. The These are essentially the same functions now. Whoa. All right. So there's a normal function, takes in a first name and a last name, and then returns this string. Your first name is whatever gets passed in. Your last name is whatever gets passed in. Why did I do this? Let's make it consistent here. Last name. Whoa. Last name, and what do you want here? Last name. Cool. All right, so these are essentially the same function right here. These are essentially the same function. And down here, why did this get moved over? Got moved over to the same things. So I could do first name, first last, and I could pass in Aaron again. Brooks. All right, so I could call the function like that, but then I could also call, and actually I would have to print this as well. Print it. And then I could also do the same thing down here. So, pass in Aaron, pass in Brooks. All right, same function, spread them out a little more. Run two different ways, one with a lambda, one with a thing. Whoops, first name, last name, invalid syntax, no comma here. Again, a comma needs to be there to separate them. And we run it here, we actually get the exact same thing. Your first name is Aaron, your last name is Brooks. First name is Aaron, last name is Brooks. So it can take in multiple arguments, just like this function can, because it is a function. And then it can only have one evaluation though. So like this is the only thing that will run, and it will return whatever it evaluates. It will evaluate and return it all in one line. I could not give it more things to evaluate. Like here, I could give it, in this function, I could give it all kinds of stuff to evaluate. I could do, well, not after this return statement, but I could give it a bunch of stuff to do before the return statement, and I could evaluate multiple things. So that is the difference. A function, a regular function, a normal function can do a return, evaluate multiple things and return whatever. A lambda only does one evaluation. You can pass in as much stuff as you want, but it only does one evaluation and returns that thing. Returns one thing. What did you say the use case for this was? Again, I'm pretty sure the only reason to use it is syntactic sugar to make it just a smoother, kind of cleaner, maybe cleaner for you, a cleaner way to kind of create a quick function. It's kind of a quick, concise way to create a function. If anyone knows any like very specific times where it's better to use a lambda, definitely let me know. But yeah, it's kind of a field thing. I use them when, again, it makes sense, when I just need to get one thing back, and it's pretty obvious what's going on. Otherwise, I just use functions because I think it's more readable. Yeah, I never use it. Yeah, a lot of people don't use them, but I want people to know about them. But I imagine if you had a simple operation that you needed a bunch of times, yeah, in a short section of code, it could be useful. Yeah, again, it is extra. You do not need to use lambdas. You don't need to use them. Flat out. Cool. So now you know something else. It's just, again, another thing to add on that, again, you can practice. You never have to use it, but something good to talk about in an interview. Talk about anonymous functions and lambdas, and kind of knowing that they can only evaluate one thing and return one thing, but they can take in lots of arguments. Good to know. Now, what time is it good? 30 minutes left. Last thing that we have here, the biggie here. Well, functions is a biggie, but scope is really important. And scoping is, I can't tell you, like it's usually When you're trying to run through a problem and you believe things are right, things aren't going well when you're building an application, and you're trying to figure out what's going on. Scope is very often what the problem is. So I'm going to pass this along because this is a full breakdown of scope. I don't think you need to know all this stuff. I think it's a good read through. In the terms namespaces, I think can be confusing because a lot of people don't refer to scoping. They don't use the namespace word to kind of talk about these things. A lot of people don't, but it is what they are. I think it's good to know. But scoping is the priority in the order in which information gets passed down, the levels in which information gets passed around, and where it is actually accessible. So let's talk about some things here. Let's actually copy this code here. Copied. Let's see if it's going to paste it fine in here. Usually it doesn't. We can put it in VS Code if not. All right, cool. It did paste it right for me. It shows me some spaces here, which is nice. All right. So say global namespace. I'm going to change this again. Namespace is correct, but I'm going to change these to scope for now. So with scope, we already talked about kind of each function kind of having their own scope. A scope is simply the area in which matters. Let's actually look up the definition of the word scope. What does scope mean? And again, we'll probably get a couple of different things. We'll find one that works for us. Yes, there we go. The extent of the area or subject matter that something deals with, or which it is relevant to. This is a perfect definition of scope. The extent of the area or subject that something deals with or which it is relevant in. What's up, Alex Beeve? Welcome. Thank you for the follow. Welcome to the channel. And so that's exactly what it is here. Everything isn't available or relevant throughout your code. You can use scoping to you can use scoping to your advantage for a lot of these things and to access data. But it is very important to know how to use scope because you're going to, again, need to be utilizing data. You're going to be needing to pass data around. And so it is very important to understand the order of how things work here. So the first scope that we're going to talk about is the global scope. And actually, I think in here, in the thing that I sent over, the link that I sent, I think they actually start talking about the built-in namespace, which actually goes above the global namespace. So built-in namespace is kind of everything that's built into the language itself. But the global scope is at it's not at the very top of the file. It's at the furthest end. Remember, Python, the spacing matters. So what is global scope? Global scope means that everything in this file will have access to it. It is available globally to this file right here. And so when you see things, on the very first line that you can start writing on, this is the global scope. Everything here is on the global scope. It is not nested underneath anything else. It is available globally. So this function is available globally. This variable right here, var1, which equals 5, this is available wherever we want to use it inside the app. This is great. And so let's show some things here. So we have var1 there. We have var2 here. So it lets us know that var2 is in the local namespace. So the local namespace or local scope, it is scoped locally to actually, I forgot. Easy goodness, I forgot to go over default parameters and name parameters. We'll go back and do that in a second. Completely forgot about that. So these things right here, these are scoped to this function here. So they're nested. White space matters. So the indentation matters. So the next level of things is right here. And these things, this variable 2, and this next function are only scoped to this function right here. to this sum function, they are not available globally. You cannot access them globally, and we'll see that in a second. And then again, it's the farther that still applies, the farther and farther you get to the right. So it's for Python, it's from left to right depth. This is pretty much for every language, but left to right depth is how you do that. So let's try to see what happens when we do some of this stuff. So let's print out. So in the global scope, so we're typing on this first line, which is the global scope. It is the global area in which these things matter or are accessible. So we'll print var1 here. We'll try to print var2, which var2 is right here. And we'll try to print var3, which is here. And we're trying to print them on the global scope. So let's see what happens here. And when we get it here, we actually get the first thing to print. We remember var1 is in fact 5. And we get, what's up, Alex Beeve? Thank you for the sub. Welcome to the family. Appreciate it. Join the Discord. Everyone who subscribes, join the Discord. You can get access to the Google Classroom and the info there. So cool. Nice to be here. Thanks for the shout out. Yeah, absolutely. I'm glad you're joining. Hopefully you get some good information. We can all get better together, because we're going to dive deeper and deeper into a lot of stuff that I don't, well, not in this boot camp in particular, but there are going to be some boot camps where we are testing the limits of even my knowledge as well. But we're going to go through it. We're going to have a good time anyway, but that's later. More to come on that. But we can see here, it printed out 5. If we look back at our code, I'll just cat it. We printed out var1 is 5. So printed that out. And then it ran into a problem. It says on line 15, where I said print var2, this is line 15 right here. You can't see it right here, but I'll show you. It says name var2 is not defined. We can obviously see var2 is defined here. And again, scoping matters. So because this is the global scope, var1 is in the global scope, everything has access to it. But down here where var2 is, this is locally scoped to this function. So I cannot reference var2 outside of this function. It does not exist outside of this function. So if I want to print var2, I actually have to do it over here in this function. So if I put it right here on the same level, as long as I put it on the same level here, I can print it. So we know that variable 2 is not available on the global scope. And maybe it's beneficial to leave this here and let's put a little comment here. So put some comments in the back real quick. Let's see, available globally, because this is the global scope, and we can say not available globally. And we can also say again here, not available globally. Let's actually take all of these things. Let's put them in this local scope and see what happens when we try to do them there as well. So we're gonna print these here. Wow. Undo. Wow. I'm struggling over here. Yank them. Faster ways. All right, so we tried them here globally. Let's see what these do when they're scoped to the second scope. So again, this one is actually kind of complicated because of how much it indented them. We're gonna try to print these things in the second scope. The second scope is everything that's in some func. And how do we know it's the second scope? It is because it is the next level of indentation. That indentation in Python does in fact matter. I know, yeah, shake all the back, yeah, all the back keystrokes. I know, whew. Cool. So let's take a look at that and let's run this now. So, oh well, that was actually what did it error on? I didn't see how I'm moving too fast. Sorry. All right, give us an error. It says line 8 available globally. Inconsistent use of tabs, spaces, and indentation. Interesting. Let's look at that. I don't know what that is. An 8. Is it because? Oh, well, I'll pull these off. Can I not have these? Bar 3 needs print. Hold on, let me see here. Bar 3 needs print at UTS level. The prints aren't using. Prints aren't using spaces. The prints aren't using. Oh, okay. I gotcha. Gotcha. Thank you. Oh, that's whack. Whack city. See, I don't actually, you know what? I don't know how to, you know what we're gonna do? This is when we're gonna use, my Vimfoo is not good enough to fix this easily. So we're gonna use VS Code. I've been defeated for a second. So let's do this. Whoa, this is not what we want. Don't save. We want scope.py. All right. No, this looks right. Let's see if, and then them, and need super whack. That's why I use an IDE to handle it. Yeah. Would you even need that first print? Oh, and the statement. You're saying this print right here? No. So I'm actually just showing. I want to print them all. I want to print them all only so you can see what each number, what it has, each item, what it has available to it. Oops. What's happening here? Oh, I forgot I could just hit the play button. This is great. Inconsistent use. Ah, this is whack. Hold on, let me fix this really quick. This is super. I should have copied this. I don't know. I actually don't know of an easy way to do. How do you open up your VS Code like that? Oh, the way I opened up my VS Code from the command line is I typed in the keyword code, and then the file that I wanted to open, the dot means right here. So it opened up VS Code right where I'm at currently. If you're on this will work by default on, I think, both Linux and Windows. If you're on a Mac, go ahead and hit Control P. Then you hit Control or Command P, and you type in like this little arrow, and you type in like start typing in install. There's like an install in path option that you can go ahead and do. Oh yeah, the finder. Oh, so I can just find and replace. Is Control H the find and replace? Oh, nice, cool. I'm learning a little bit about VS Code here, and okay, the tab character. Where's my backslash? My backslash is not. There we go. Backslash T. But I need the quotes backslash T. Tabs, and we'll replace it with spaces. Tabs and spaces are very, very interesting in all language. Well, not languages, all editors. I'm gonna replace all and results. Do I have to change it to match case, match whole word? Do I have to use you don't need quotes in the place thing? Cool. No results. There are no tabs in here. There are no tabs in here. Can I just do this? I just want to see if this will work. Oh, look at that. But okay. So these are different than those. All right, man, this is super whack. I broke everything. I should have just typed it out, but it's fine. I wonder, let's see if this ride itself just works before I do the. Bar one. Yeah, it's super weird. All right, here's what we're gonna do. We're wasting our time. Here's what we're gonna do. Watch this. We're gonna do one ourselves. Actually, we're gonna delete it all. How about that? Just because sometimes when you get frustrated, you just delete everything. And let's take a look at what it was, and let's just quickly do this. So let's set again var1 equals 5. We can keep it the same. Equals 5, and then under this, what does it look like? We have a def some func. So they set up a function here, and they set up a function here. Now, and then in here, we set up var2 and some inner function. So actually put on the same line. var2, did it set equal to anything? Yep, equals 6. And another function. So let's put a space here. Def some inner function, and we need these. Whoa, Z. All right, and what's in some inner function? We just have var3. var3 equals 7. All right, this should fix all of our issues, I hope. So global scope, and I'll put some comments in here so we know. Global scope is up here. Everything that's inside of some func is the local scoped. It will be local scoped to some func. Everything that's in some inner func will be local scoped to here, but it will have access upwards. So right here, we're going to print var1. We're going to print var2. This is another reason why I love and hate VS Code, because of all the stuff that pops up while you're typing. Love and hate it. Most of it is valuable, and I know you can turn it off, but it can get annoying to me sometimes. So let's run this. We're gonna print all 3, and let's see what we have access to. Again, we got 5, but we don't have access to 2. var2 is not defined. So let's take all these 3 lines, and we know this doesn't work, so we'll comment this out. Actually, we know that var2 doesn't work, so let's comment it out. What happens with var3? var3 is not defined. Again, var3 is locally scoped here. It is not available globally. Let's go ahead and comment that out, since it doesn't work. So here we can just print var1 and press play, and it prints var1 and it exits accordingly. So now let's see which one of these are available in this next scope. What's locally scoped here? All right, so now we're in the sum func. We're scoped to this. So variable 2 is set up here. Let's see what happens when we try to print everything. Save it, press play. So when we do this, it says, okay, I'm doing something. What am I doing wrong? I'm doing something else. I'm doing something different wrong. Here, unindent does not match any other indentation level for var2. Did someone already tell me what I'm doing wrong and I missed it? I don't know why this is happening, because it didn't even print line 5, like return. Well, no, I should still. Well, one is because I'm not calling the function first off, which is fine, but like, why is it giving me an unindent error? I could return var2 to receive it on the global scope, delete the white space and use the tab key. I mean, I'll do that, but I'm using the tab key, but inconsistent. It's weird. This is really weird. Okay. Did I not save it? Because it ran. Oh, maybe that did fix it. Oh, okay. Fix it. All right. So it's still printing out 5. I guess that worked. Thank you, UC Goodness. I could have sworn I used tab there. But all right. So I printed out this. It's still just printing this. I'm not calling some function. So let's call some function and see what happens. Let's go def. Not def. I'm gonna call some func. All right, so we're calling that function now, and let's see if it prints out what we want it to print out. So we're gonna see what it has access to here. We run it, it prints out 5. So that's actually this thing here. Then it prints out 5 again, which is because we called this function. So it does have access to this. Then it prints out 6, because it does actually have access to 6. It has access to 6 because 6 is created here. So it does have access to these 2 things. But it does not have access to var3. And again, from the command, you can see, whoa, how do I open up my control? Darn it. Save, let's run it. So cool, so we commented out 3. Basically, it says var3 wasn't defined. We did not have access to that. So let's take a look at this. Again, everything moves from left to right. Over here on the left, anything defined at the left is available globally to everything. So you can see that even though this is defined over here on the left, as you move right, it's still available. What's up, welcome, thank you, thanks for the follow. Welcome to the channel. You can see that it has access. Everything as they move right has access to the things that are above it. So at the scope that is above it, the global scope is available here. So it does have access to var1 and it has access to var2 because var2 is locally scoped to here, but it does not have access to var3. Why? Because var3 is created here, which is another indentation level in, and it is locally scoped to this inner function here. So now let's see what's available here. I hope this doesn't give me some weird errors. And actually I should actually put some words in here so you know which scope this is. var2 and print var3 and save it. And let's run it. Actually, it doesn't do anything because we did not actually call this sum inner function. So let's call this sum inner function. Sum inner function. We'll save that. We're calling sum func. We're printing var, we're calling sum func, and we're calling sum inner func. Maybe we'll just, for now, so it's not too much output, maybe we'll comment these out. And we'll just call sum inner function, which is this function here, which is kind of the 3rd local scope there, or 2nd local scope. And we'll print this out and we get sum inner function is not defined. So this is also interesting. Why is this not defined? This is not defined because of scoping. So we cannot call this function from the global scope because it is only available inside of this function because it's defined here. So things don't work backwards. Globally, we cannot access this. So we'll actually call it here. We have to call it here. That should work. We might have to call it beforehand, afterwards, but we can call it here. We should be able to call it here. Same thing. Let's delete, tab it. Whoa, save it. All right. And so now if we try to print sum inner function, what happened here? Oh, it's because, hold on. I thought Python was smarter than that, but I guess it's interpreted, so it kind of goes line by line. So when I run this, nothing happens. It runs, we get no error, but basically it doesn't print anything out as we expect. And I guess that's because sum inner function is defined after this. And do we have to put this behind? Again, indentation matters. As long as I put this on the same level, it is still here. And again, let's do that. I need to call it. Really? I didn't think you need. Oh, seriously? I thought if I defined this in the second scope, I would be able to call it. So you're saying me I need to call some func and then call some inner func? I didn't think that was the case in Python. I don't know if I like that. I don't know if I like that. I don't think that I like that. So you're saying something like some func, you defined a big function but never called it. Oh, like, so you're saying I never called it in here, out of here? Let me see. Let me see what you guys are talking about here. It's interesting to me. I don't know why I feel like you should be able to. First off, I never program like this. First off, I never put a function inside of here like that. But so call some func in the same. Should I call some func in this scope, or should I call some func on the global scope? Does it just have to be called and to be available, or you're saying go ahead and call like recursively call it globally? So I called it globally. And then are you saying that now I can call some inner func in the scope, or are you saying that I can call it globally as well now? Line 15 is fine. So you're saying some func here and just run this. You're saying just run this, just run it as is. Just run it. Okay, you say just run it. I'll just run it. And we get 5 and 6. Why do we get 5 and 6? We get 5 and 6 because this is here. So obviously then call inner func within some func. Gotcha. Which makes perfect sense. I don't know why that was escaping me. That makes perfect sense. Because I would have to call this for this to be called, for it to execute anything that was inside of here. We'll remove these print statements as well. I don't know why that took me so long to get to. So we'll call now some, I guess I can't even, well, it's not giving me this option, so I don't think I can call it beforehand. And now you'd have to call some inner func inside some func. Would it have to come, for Python, would it have to come afterwards? Let's see. Will it give me this access to this now? And it does. So it has to be after is defined. I don't know why I thought Python was smarter than that, but I guess because it is interpreted, that makes sense. So now when we print, that didn't do. Oh, that was dumb. That was really stupid. There we go. I didn't make it a function. And when I do it, now I get all three numbers. I get 5, 6, and 7. So this third scope, or really it's not third scope, it's really the second scope, but this scope here actually has access to everything. It has access to everything that was created before it and up to what it has now. So again, left to right. I think initially it may seem more reasonable that everything from left to right should basically pass down. I mean, be at least the first time I looked at this scope, I thought it would actually be the opposite. I assumed everything that was, I don't know, like that was defined all the way deep in here because it was nested under a bunch of stuff should be available all the way up, but that is not the case. It goes globally. Globally is available to everything, which makes sense for the term globally. It's globally available. And then as you move to the right, you lose access to things that are locally scoped to those different things. Can you try calling some inner func before it is defined? Yes, let's actually do that. I don't think it's going to work. The only reason I don't think it's going to work is because I assumed it would, is because when I started typing, it did not give me some inner func as an option. But we can go ahead and we can see, and we can paste in some inner func and save that. And it lets me know local variable, some inner func reference before assignment. So that is, again, because we were calling this before we called it other languages, statically typed compiled languages. It does not care the order. So you could do something like this. But I do think it's better to, just for consistency's sake and for understanding the code, that you do this in order. It makes more sense when someone's trying to understand the code that you're writing, no matter what programming language you're using. This makes much more sense. We defined it up here and we're running it again in the same scope, because remember, indentation matters. So because these are on the same line, they are of the same basic scope and value. Like there's no change in precedence between them. They're the same place. The same place that this def is getting set up is the same place that this is running. So scope can be, again, a little annoying to kind of get your hands on the first time around. Take your time with it. Mess around with it. You can do all kinds of different stuff. You can take this. I'm gonna push this to GitHub. You can take this and mess around with it if you want. Copy and paste from the page that we copied and pasted from. But scope is very important. You have, when you're writing an application, you'll have lots of levels of scope. It won't just be one or two, it'll be many levels of scope, and there'll be multiple functions, there'll be multiple files, there'll be all kinds of things where the scope matters and certain data isn't getting to where you want it to be, or values aren't getting passed the way you need them to get passed, again, because of scope and making sure you get things out of there. So again, these are functions. So how could we get some of these values out of here? Is we could do things like return to var2. And if we returned it, we can now access this data elsewhere. What's up, Lucky Wonder Boy? Thank you for the follow. Welcome to the channel. But you can get it outside of here. So that's what the return keyword is for. That is how you use data outside of the scope. We remember that's the words we use. If you want to use the data outside of the scope of the function, go ahead and return that data. But again, you can only return, you can return multiple values, but you can only have one return. So again, you can use these things in a bunch of different ways to be able to solve problems. And was that the end of the slides? That might be everything, and we might be ending right on time. Look at that. We got through it. We got through it all good. Python Zen isn't a joke, is it? It is not a joke. It was never intended to be a joke. Well, kind of. Like, it's supposed to be a fun list of, if you're talking, I'm assuming Python Zen, you're talking about the list of those 19 things or whatever. That's what people call Python Zen. It's, it's not really, I think they originally intended it to be right and fun, but I don't know, man. It's not. Python's just gotten too big for that to be right. As a bonus, can you go back to your Vim and resolve how to fix the edit you had? So great question that you go. The problem is that I fixed it in I fixed it inside of here in the same file. I didn't create a new file. I fixed it in that same file, so it'll be fixed in Vim. And the reason we had that problem, just so everyone knows, the reason that we had that problem is because in computing, especially in Python, and something that cares about white space, different ways people put in code, they insert certain characters. So when I copied and pasted this, there are actually characters for either tabs or spaces in here that actually you can't see them, but they get inserted into your code. And again, Python cares about white space. Just trying to practice Vim and regex. Yeah, so we can go back to Vim really quick. Let's move this down and move this. Whoa, see, undo. I'm not saving this because I was trying to use some cool tricks, and there we go. So Vim, scope.py. So they are still there actually, and I guess because I did them in VS Code, that happened as well. If I paste in, it's still the same. So that's interesting actually. So you can see these dots and arrows over here. Take a look at if I do. This is just a Vim indicator to show me what things are spaces and tabs. So you can see here, I bet if I did something like this and I try to do a print on var2, let's see, let's try to do a print on var2. Let's go ahead and delete. Let's delete this stuff. All right, this is probably gonna fail because you can see here, it doesn't have the same white space basically as this has, even though visually it looks to be on the same line, it does not have the same white space. So it's probably gonna fail when I print, when I use SumFunc. I have SumFunc here. It should print out 6 at the first item. So let's go ahead and run that. Python 3, scope.py. Oh, that did work. That's interesting. I thought that was actually not gonna work. So what happens if I do, probably because it entered it. What happens if I do tab? Let me see if this works. Python 2, Python 3. Okay, it's Python 3 problem, not a Python 2 problem. I didn't realize I was typing in Python 2. So Python 2 makes it work. Python 3 does not let it work. That is very interesting to me. Does it insert it correctly if I just do this? Probably not. It doesn't. Okay, so let's see here. I see a lot of stuff here in Python coding. When to use a comment versus a doc string. We'll go over that in a second. It's a good question. You wanted to do an argument and default parameters. All right, yeah, we'll do that. I find that you can do Control V or some substitute. Like a sed. What's that set? Hold on. Can get used to like regex and substitute. So you're saying like in Vim, like the like it's like the slash sed here. So it's like, what is it? Slash like S and thing, and then slash G to replace it globally. We can go to that in a second. Yes, there you go. You put it here. Yes, that does work, but it doesn't do the special range. So I'm really bad with regexes, so I do not know how to do the special range, but your syntax is mostly right. I think you need a G in there. I think you need it's %s. It is %s. Let's see, and %s. And I can do like I can replace SumFunc with like with Aaron, and I can do like a slash G. And you can see here, everywhere SumFunc was, it replaced it with Aaron C, because that's what I typed in. I misspelled my own name there. So I can change %s. I can change Aaron C back to, can't see my keyboard, SumFunc. So I can do that here, and you can see it does it immediately. So that's what the ego is talking about, is using regexes, regular expressions, to match patterns inside the code and to do find and replaces. You can use those very easily to fix tabs and spaces and things like that. The only problem is I wasn't sure of what I needed to fix, because I don't know in my Vim if these are like what characters these are. I don't know what characters are getting inserted here. It could be a line endings problem as well that's causing these. We'll talk about line endings another time for sure. I think it'll fail on line 17 if you use Python 3. Yes. Well, it actually fails on, use Python 3, it fails earlier. One out the bottom. Yeah, it fails earlier. All right, and let's go back to, really quick, let's go back to passing arguments. I'm gonna try not to look at my keyboard. I'm getting really bad at doing this on stream. When I'm normally typing, because I can see my keyboard and my peripherals, I'm fine, but because my mic blocks my hands in the keyboard, it really throws me off, like really throws me off a lot. So I have a lot of trouble. All right, default values. So you can set default values, like if you know someone may not pass in something properly. Let's go ahead, let's create a new file. Vim func, and we'll call this with default.py. All right, and so in here we can do something like def. We do add again, and we can do, maybe we should want to add 2 to everything. We can do X, we can set it equal to a value actually, and comma, and Y, and let's do return X plus y. And let's print 4 comma plus 4. Let's see what happens when we print 4 plus 4. You see I set it, this is how you set a default value. But what happens if I run Python 3 func default.py? Non-default argument follows default argument. Whoops. I think I actually didn't know that. Do you have to make both of them? You have to make both of them default for this to work? Interesting. I did not know that. It returns 4 plus 4. Very interesting, actually. I just that was dumb too. That was really dumb. Man, I'm struggling. It's getting late. Ooh, okay. I was like, what is this doing? All right, so we'll talk about what I just did in a second. So, so you can set a default value here for an argument. It said default. So I set a default value here, and default value here. But if you pass in things, it will override them. So if I pass in a positional argument 4 and 4, it will take the place of this default value, and it will return x plus y. Default values. I didn't know this either. I didn't know you had to have default values after non-default values. So if you do, so I'm assuming you mean like this. And would I just not pass in one of them? Is that how I would enable it to where y is now 2? And try to run this. And cool. So actually, you see how I didn't fail here. So remember I said in the slides that you must pass in the number of arguments that is defined within the function definition. Not if you use a default value. I generally stay away from default values. There are times when I've had to use them, and I've seen them used actually a lot. It makes sense a whole lot. But I actually didn't know they needed to be defined second. So that's, again, another learning thing. That's great. Default values after non-default. Otherwise, the interpreter doesn't know which variable an argument is assigned to. That makes perfect sense. That makes, spot on, easy goodness. That makes sense to me. We're basically done. This is some extra, which is pretty cool. That makes perfect sense. Because it's positional. I assumed that Python would be smart enough to say, all right, no, that makes sense. That would be dumb because it's just a default value and not a defined value per se. That's cool. That makes perfect sense right there. So again, if you don't pass anything, it will take a default value, or you're more than welcome to pass in an item that will override the value that you passed in, which is default. So just like that, we passed it in, and we can see here that 4 plus 6 is obviously 10 rather than 4 plus 2, which is 6. So that is a default value that you can pass in. We were going to go over something else. I think somebody asked about something else, but does anyone have any questions about default values? Or does anyone have any anything additional to add about default values that maybe we didn't talk about or don't know? Because that was very quick. Just something we threw on. Don't specify positional arguments after named arguments when calling a function. Oh, can't specify positional arguments. That makes sense. So that makes sense to me. It's like you can't go ahead and throw in like another y or like z and then do like plus z. Can't do that, which makes perfect sense to me. A 6 again. Then we run it, should fail. It does. But if we made the last item the default, it must always need to be the last item. Can you do multiple last items? Can you do like z and then comma like a equals 56, and then do plus a. Cool. Yeah. So you can have as many default functions as you want after all of your positional arguments, which makes perfect sense. Oh yeah, you have to skip the range, the s slash that backslash s. That makes sense. Oh, okay. Okay. So interestingly enough, I didn't know you were saying the word range, but I wasn't actually like my font is small on my monitor in front of me, like the big monitor in front of me, and I couldn't see what you had in there, the bracket 4 comma. So that makes more sense to me now. And no space after the comma for unlimited range. That makes sense. That does make sense. Because name arguments allow you to change the order in which you pass arguments, so the interpreter can't guarantee the arguments. Yes, it makes perfect sense. Definitely makes. I certainly understand that. That's good. That's good to know. What was something good to remember? These are all the little. These are all the. I don't want to say little caveats. It makes perfect sense. But these are the things that make programming a lot easier as you pick up things over time. Yeah, just stuff like that, like knowing things like this. I will try to remember this. My problem is I keep diving into other languages that aren't Python. Even though I love Python, I don't use Python for my like local automation anymore, even though Python is excellent. And so I'm probably gonna forget that, but I'm gonna do my best to remember that. So that I can become a Pythonista, the best Pythonista. All right, I guess technically you would use 3 instead of 4, clean everything with 1,000 spaces. Oh yeah, yep. All right, cool. That's it for tonight. We usually don't, it's 10:15, not too late. So what are tangible takeaways for the night? The tangible takeaways for the night are functions. You learned that functions are a reusable block of code. We learned that how do you create a function? You create them by using the def keyword. And again, that's so you can define what the function is, and you give it a name. We learned that they only run when they're called upon, and they're called by name. You have to call them by name to run them, and with some parentheses after it. So that's how you call a function. We learned that these functions can take in data, and they can do some processing, and they can push out data. They can return data. The data that's passed in is passed in as something called an argument. And you can pass in as many arguments as you like. You put them inside of the parentheses and you put a comma in between them. You have to pass in the same amount of arguments that are defined in the function definition. But we also learned that unless you are using these default parameters, you're setting default values for these parameters, you have to pass in the exact amount that were used. We learned that to get data out of a function, the processing and the things that go on inside of a function are locally scoped to that function. To get the data out of it, we have to return that data. So if we want to use data, we have to return that data. We can also return multiple values. We can return more than one value. We can return multiple values. How do you do that? The same way that you pass in things, you separate them via comma, and you can return multiple values. We also learned about lambdas, these quick one-line syntactic sugar functions. They're anonymous functions. You'll hear anonymous functions in other languages as well, but it allows you to quickly and concisely create a function. The caveat to that is they can take in as many arguments as they like, but they can only evaluate a single expression and return that one thing. So, if you need to return more things than that, or be able to, return multiple items, or to evaluate multiple expressions, you need to use a regular function. And then we also learned about scope. Scope's a little tougher. Scope's something you're gonna have to play with, but scope is the area in which things kind of make sense, things matter, and it also defines what in your code has access to what data. Again, remember, everything that's all the way to the left, everything that's up against the margin over here is your global scope. Python is a language that cares about white space. So over here is where everything starts, and each indentation level specifies a new area of scope. There are some caveats to that as well. But as you move to the right, as you scope things farther to the right, things are only scoped to that place and down. So if you have everything on the global scope, that is available to everything behind it. If you move over to the first local area, this is now everything that's defined here is available to everything that goes this way, but not to anything over here. And as you go down, it works like that. It's available to everything on the right, but not to the left. And you can have some fun playing with those things. Scoping is fun. That's it. That's everything that we learned tonight. Very, very exciting. This is good stuff. We've now gotten to the end. We've gotten to the end of what of, again, all the main things, all the like main tools you need to solve a bunch of problems were there. Now there's a bunch of other stuff, error handling and object-oriented programming and stuff, but we're at the problem solving area now. We can use these functions to package up everything else that we've done, to write, little pieces of functionality so that we don't have to write a bunch of code to be able to solve problems better. Now, when we hop into Exercism, they kind of give you some functions for some of the beginner problems. Like out of the box, they'll kind of provide them for you. So that's good. So now we know what we're looking at when we're diving into those things. That is what we'll do next time. Next time we will learn, again, some of the common problem-solving paradigms. We will learn how to do those things. It's interesting because we probably won't dive deep into problems that use some of these big level, like, yes, we'll do bubble sorts. Yes, we'll do that stuff. But like, we're going to focus on more broad, like word problems that help out a little bit, I think, for more day-to-day things. But I'll teach you the concepts and things that you need to learn to solve these algorithmic problems. Although we're going to be using code to solve these things, think about these things separately. Do not get confused. Like when we're going over these things, this is logic. This is the way that you're solving these things. The way that we're going to be going over these things is doesn't really have anything to do with coding. We're just going to use programming languages to solve them because they're problems that are set up to be good to be solved by programming languages, but it's really logic. So we're going to be learning a little more than code here. We're going to be learning a little bit how to think, and that's where these algorithm sections are really going to help. Just think of how you think through a problem and solve a problem. So yeah, that'll be coming later this week, and then we'll get into more stuff to make you a little bit better, which is going to be pretty exciting. So cool. Any questions? We do object-oriented programming in Python. Yes, we are going to do object-oriented programming. We are going to do, I never put up the, I'm in DevOps now. Yes, object-oriented comes pretty soon, actually, I think. Oh, no, it doesn't. Well, like 2 weeks, I think. We're going to have 2 weeks. Yes, we'll have 2 different classes of object-oriented programming, which when Python gets pretty powerful this way, object-oriented programming is really cool. And we're going to use this to start to do some projects. The first project, I haven't pushed it up yet, but the first project will be Blackjack. We'll be playing a game of Blackjack, and that one's exciting because I tried to think of something cooler. I told you this before. I tried to think of something much cooler than Blackjack, but I now understand why so many courses use Blackjack as the first like big project that you do, because it covers all the concepts and it's a little bit fun because it's a game. Because it's a game, so it's pretty fun. So that's what we'll do for the first capstone project. We will build a game of Blackjack. We'll use our object-oriented programming concepts. Again, you got to make your decks of cards. You got to keep track of things. It's really nice. And I have some cool information about the Capstone Project 2. The Capstone Project 2 will be a much bigger project. We will not finish the Capstone Project 2. We will do just enough so that you can go off and finish it in your own time. You have some freedom with it, but yeah, it'll be fun. We can leave you, like, we'll be able to leave you with it and play with it, and it'll like, we can always come back and help each other out, but it'll be, I wanted to leave you with something, and then, then we'll talk about how to, apply this stuff to be able to get a job and do a retro. If you're interested in DevOps, we just started our introduction into cloud computing with AWS. That stuff's super cool. So you can dive in. We're going to be going over part 2 tomorrow. It's a 4-part series for cloud computing, but you can check those things out if you want. If you're at all interested in anything in the cloud computing piece, but you only really care about programming, I would tune in to this part 4. I highly recommend tuning in this part 4. While I probably won't use Python, I think serverless computing is really a great thing for software developers to learn and to know. So starting to get your hands on that might be pretty cool. It might be pretty cool. So tune in if you want that. Yes, we did have a stream yesterday. Everything goes up on, I'll put up it'll still be on Twitch, so if you need to see it, you can put it on, you can see it there. I'll probably just upload, because everything's up here for 14 days, I'm just kind of waiting till the end of the week to upload the whole week of videos to YouTube, but everything else should be there. And we are not going to be writing any tests, but because we are using Exercism, we will be learning about unit testing constantly, because again, you can't the unit tests that come from Exorcism, you actually have to code to solve the tests. The tests are written for you, and you have to code to solve those tests, which is really nice. Which is it's very helpful actually. And we're going to talk about how to approach that. So yes, we will also talk about the different types of testing. I'll try to get to that. We'll try to get to that sometime. And we'll probably write some unit tests for when we get to the capstone project. We'll probably write some unit tests. I might also have to extend I'm either going to extend the streams for both of the capstones by an hour to 11, or I'm going to provide a significant amount of skeleton code. Not sure which one I would like to do yet. Maybe throw your idea out there if you prefer one or the other, just because we need to be able to get through it in 4 hours or whatever. But yeah, we will figure it out. We'll see what works. We'll try it out. But cool, that's it. That is it for tonight. Thanks everyone for joining. We went a little over tonight. Usually we don't. Skeleton code would be awesome. I actually do think that's, I thought that was the better option, to be honest. Skeleton code would be great. Cool, that's what we'll do. I'll get some skeleton code written out for that, so that we can kind of fill it in together, and kind of provide us some guidance, so that the cognitive load will be a little bit less, so we can really understand and focus on the concepts that we're going to be going over. That is it. Is there anyone online right now who we should hop over to? I'm sure Dowright's on. I don't know if Primogen's on. Anyone cool online right now? Let's see. Dowright as usual. Last Miles. Let's see Last Miles. Let me just check out Last Miles channel. Oh yeah, the Gandalf guy. That guy's very interesting. He's very interesting. We've done Dowright a bunch of times. Let's head over to Last Miles. We're gonna head over to Last Miles. We're gonna raid him. We'll see what happens. Let me know how you like this guy. We'll stick around and check him out for a bit. Everyone have a good night. I'll see you on the DevOps Bootcamp tomorrow if you're going to be on there. If not, I'll interact with you on Wednesday when we hop into some algorithms and start using all the stuff that we learn. Thanksgiving stream, absolutely. What's that? Was it S4? E4? I can't say the S4. No problem. Definitely have a good night. Now it's time to do some PHP unit tests. Good luck. I'm terrible with PHP. The guys at Cisco are releasing some DevOps certs. What are your thoughts about them? I'll check them out. I didn't know that actually. I'll check them out. I think DevOps certs are hard to do because DevOps is not, it's a methodology, and a lot of times they try to just combine a bunch of tools to say you're good. So it's really weird, but yeah, we're heading over to Last Miles. That's kind of my thought on them. I'll check it out and see if they're good. Maybe they have done it well, but yeah. Towards APIs and networking stuff. Yeah, I'll check. Like I don't know. Something DevOps specific seems a little bit weird to me. I like them to be more either application. I like them to be more application specific because then you can truly test the knowledge of the application. But DevOps, like there's just so much variation in what you're doing. It's kind of hard to do, but all good. All right, heading over to Last Miles. Everybody have a good night. We're gonna head out in, wait, that's him. 7 seconds. 5, 4, 3, 2, 1. Everyone have a good night. Let them know that we said hello.